So I wish all very very successful academic year, and you are doing this year your O level exam 2022 O level badge. Actually, this year you are supposed to be in grade 11, right? All the government and semi-government schools, but you will not be starting your grade 11 work until the previous batch pass out from the school. So they are doing previous batch, they are doing their O level in 2022 this year May. So you will be promoted to grade 11 after April, right? After their third term test papers. And but anyway, I'll be starting. I won't wait until March. I'll be starting your grade 11 work by end of this month. By third week I can start parallel to the grade 10, because we have to discuss about 3 more chapters grade 10. But I don't need to do this in a hurry, because you have enough time. Most probably your exam also will be postponed under this situation. So it is scheduled to be held in December, but sometimes they will have to postpone, because you are starting your first term after April, right? Therefore you have to do it properly, the grade 10 work, because you know the importance of the grade 10 syllabus for your O-level exam. And this chapter 16 chemistry, because last few lessons important grade 10, because last few lessons little difficult with compared to the first term and second term work, because mostly they are from chemistry and physics. Example, unit 16 17 chemistry, 18 and 19 physics, and last one the hardest biology lesson, grade 10 out of all the biology lessons, that is inheritance or genetic lesson. Therefore the last few lessons you have to do properly, because otherwise you are in trouble. O-level paper essays and structured syllabus questions. I'll share the screen. Anyway, you are starting your first class for 2022 this year with science, so you have to be, so I'm happy about that. And anyway you have to pay more attention to the subjects, like main subjects, core subjects like science, maths, because no point of getting even 7 A's or even 7 A's if you don't get science and maths A pass. That means no point of getting A's for all the other subjects if you don't get A for maths and science. So the oral results mostly, for your higher studies, even any other private sector, or even after passing out from the school, if you are applying for a job, they ask English, maths, science, credit, at least credit pass, right? So that is your oral results. After that only the extracurricular activities and everything else. Number 2, number 1 oral results, right? Now you can see the screen. We discussed about the reactions of metals. I showed you some video clips also, how they react with different components in air. Example, basically with water, with oxygen, and third one, reactivity of metals with acids. So what are acids? Actually you have some acids in your kitchen also, like vinegar. Soda also contain carbonic acid. So acids, some acids are strong, some acids are weak. And 100% pure acid we are not handling, because we mix the acid with water. Such acids called dilute acids. So what is the meaning of dilute? If you want to write an arrow towards dilute acids, dilute means the concentration is low. Acids with low concentration called dilute acids. That means, like, if you take like a cordial bottle from the market, it's high concentrated one, concentrated, so you can't drink straight away the cordial in the original bottle. You have to mix that with water for making drinks. Same stuff, acids available in the laboratory, it's strong. You have to make it diluted by mixing with distilled water, deionized water or distilled water. So if you only can put an arrow, dilute means what? Acids with low concentration. Dilute acid means acids with low concentration. Acids with low concentration are called dilute acids. Acids with low concentration. Then what is the opposite of low? High concentration. High concentration means what? Concentrated acids. Sometimes we call it conc acids. Acids with low concentration. Acids with low concentration are, because concentrated acid dangerous to handle. Acids with low concentration are called dilute acids. How to dilute? By mixing with water. It is diluted by mixing with water. Conc acids are converted to dilute acids by mixing with water. That also, if you want, to write within bracket. Concentrated acids. So conc, I put CONC dot. Conc means concentrated acids are converted to diluted acids, can be converted to diluted acids by mixing with what? Distilled water. Can be converted to diluted acids. Look at the screen. Can be converted to diluted acids or dilute acids. DILUT. Sometimes they put D dot. Dilute acids by mixing with distilled water. By mixing with water. Otherwise, you don't know what is dilute acids. What is the opposite of dilute? Conc acids. By mixing with distilled water. What is distilled water? If you take battery water, battery shop, the battery water, distilled water, right? If you normally we use tap water. Most of the school they don't have distilled water in the school laboratory because it's expensive. Therefore, they use tap water for the practicals, but actually for the chemical experiment, so we had to use deionized water or distilled water. Deionized water is a bit more expensive than distilled water. Right? Deionized water. What is deionized? Free of ions. Sodium ion, chloride ion, calcium ion. So no other ions, like pure water. Right? So, but some gases can get dissolved even in deionized water. Like when you open the lid, carbon dioxide, oxygen can get dissolved in water. Even germs can enter into water. Right? So then what are the common acids we use in the laboratory? Look at the screen. You have to remember the formula as well as the name. HCl. Now this also very you have to be very careful. If you take 100% pure HCl, it's a gas. We call it hydrogen chloride. But if you take HCl mixed with water, then it is called hydrochloric acid. AQ means mixed with water. Aqueous. AQ means aqueous. That means with water. When acid is added into water, only it behaves as an acid. 100% pure one is not an acid. With water it is called aqueous. So even the others also same thing. We never use 100% pure acid for the experiment because it's so dangerous to handle under normal conditions. What is the other most common acid? Sometimes we call it battery acid. What is the other acid? Sulfuric acid. We call it battery. If you want to write here, this acid is present in your stomach. What is the acid present in our stomach? Hydrochloric acid. If you want to write, this is present in our stomach also. Why acid in the stomach? To prevent the bacterial growth. Otherwise, what happen if you don't eat your meal? Okay, you have the lunch packet and you are not eating. So if you keep that until 5-6 in the evening, what happen? Microorganisms will act on this food and it's get rotten or spoiled. So, but in the stomach also food remains sometimes nearly 5-6 hours. So bacteria won't grow because of the acidity of the stomach. Plus, it facilitates the digestion of food also. Acids helps to digest protein. Helps to digest protein and to prevent the bacterial growth. The stomach contains hydrochloric acid. So this is battery acid. Battery acid. So batteries contain what acid? Sulfuric acid, battery acid. And nitric acid, sometimes we call it Gini Vatura. Nitric acid, that is used to make explosives. Pupurana dravya, explosives. To make explosives, we use nitric acid. Most widely used acid in the lab is hydrochloric acid, dilute HCl, right? Not conc HCl, dilute HCl. So you take 1 milliliter. Now you have the stock bottle. Original bottle, you have this, we call it the stock solution. So HNO3 or HCl, you put maybe 1 milliliter from this and you fill the rest with water. then it become diluted acid. Okay, so 1 ml from the original solution acid HCl, and the rest you fill with water and mix, then it become diluted. So you make it 10 ml, then 9 ml will be water H2O, and then you mix well. Acid dissolves in water, acid dissolves well in water. Any acid dissolves in water, then it become diluted HCl. Then concentration decreased by 10 times. Imagine here the concentration 1 moles per cubic decimeter, then it decreased by 10 times. It's diluted by 10 times. 1 ml mixed with 10 ml of 9 ml of water. Then total you top up to 10. Right? You can top up to 10. 1 is top up to 10 ml by adding 9 ml of water. Okay, so those things also you should know, right? Because by reading the textbook you can understand these things. You can understand these things by only reading the textbook. Remember that. Then next one, how they react with, now that what is the topic here, how acids react with metals. How acids react with metals. Will all the acid react? Okay, what are the questions that should come to your mind? When acid react with metal, what will produce? What are the products? And how they react? What are the observations? Will all there are more than 80 metals in the periodic table, will all the metals react with acid? What are the questions that should come to your head when I tell this as reaction of acid with metals? Will all the acid react with metals? Will all the acids react at the same rate with metals? And what are the observations and what are the products? Products, observation, how do they react, or how fast they react with different metals, and will all the metals react with acid? Will all the metals react with acid? No. If you take bracelet, ring, or jewelries, platinum, gold, silver, they don't react with dilute acids. They don't react with dilute acids. Otherwise you can't, you have to remove the ring, say example a wedding ring should be removed when making pol sambal or when eating amultial malu, right? Why? Because it might it corrode if the gold, or maybe okay, gold wedding ring. So or else if you are going to have a your the chain may contact with sweat, may contact with different substance. If you are going to have a bath somewhere, then it might get corroded. But jewelries like silver, gold, platinum, they don't react easily with even with oxygen, water, and acids. That's why the luster lasts for a longer period. They don't get tarnished. But out of all the groups in the periodic table, which group react fastest with acid? Group 1. Group 1 metal react. You should never do that in the school laboratory. Dangerous. Why? It can cause even severe burning and explosions. May cause explosions. Here I highlight that may cause explosions. Therefore, should not be done in the laboratory. But with group 1 metals, lithium, sodium, potassium, even group 2 metals, they react violently. Group 2 metal like calcium, not all the group 2 metals. Magnesium okay, but not with calcium. And down the group reactivity increase. What are the group 1 metals? Lithium, sodium, potassium, rubidium, cesium, and francium. But francium, it's radioactive, therefore we don't use that in this laboratory chemistry lab. Group 2 metals, what are the metals? Beryllium, magnesium, calcium, strontium, and barium. After that you get radium. Radium is radioactive. The last one in the group 1, francium, Fr, radioactive. Radium, Ra, radioactive. Radium, mercury. Right. Then out of this, down the group, chemical reactivity increase. In both the groups, down the group, chemical reactivity increases. Because that's why calcium react much faster with acids than magnesium. Reactivity increases. If you want to write that, reactivity, any group reactivity increases, not only with acids, even with water, oxygen, reactivity increases down the group. Chemical reactivity increases down the group. Both group 1 and group 2. remember, just by collecting the theory and getting a printout and completing only those blanks, you will not improve your knowledge. Otherwise, I would have finished the syllabus now, because you should be 100% okay at the end of the this discussion, this section. Otherwise, just to give the same textbook note again, you don't need to come to the, just to get the same textbook note again, you don't need to come to the class. You come to the class to have a better knowledge. Sometimes you should have a better knowledge than your teacher, right? After my explanation, you should not have any doubts. Even if you have doubt, you can clarify, you can send a WhatsApp, through WhatsApp you can make a send the questions. Okay, I'll reply that. Now group 1 and group 2, therefore we don't use, even for fun, don't do it. Don't put a piece of sodium into HCl bottle. It can cause severe injuries. That's why this, if you only can underline this, should not be done in the laboratory, the school laboratory. Then what about the other metals like magnesium? Group 2 magnesium, okay, because magnesium is above calcium. Magnesium is less reactive. If you want to prepare hydrogen gas, you can use magnesium, aluminium, zinc. Also react rapidly but not violently, right? It will not cause injuries. HCl liberate in hydrogen gas. Liberate, what is the gas given out? When metals react with acids, what is the gas given out? Hydrogen gas. When metals react with acids, what is the gas given out? Hydrogen gas. Therefore, if you want to prepare hydrogen gas, in the laboratory, you can use this reaction. You may use this reaction if you want to prepare hydrogen gas. So if you want to write that hydrogen gas can be prepared by this reaction. Hydrogen gas can be produced by this reaction in the lab. Hydrogen gas production can be done. Hydrogen gas production, we use this reaction. Used to make hydrogen gas. Can be used to make hydrogen gas. Can be used to prepare hydrogen gas. Can be used to prepare hydrogen gas. Sample of hydrogen gas. What is reaction of magnesium with HCl? Reaction of zinc with HCl. Most widely we use zinc and magnesium for the preparation of hydrogen gas in the lab. For the preparation of hydrogen gas, what are the two reactants? What are the raw materials we can use? Metal magnesium with HCl. Metal zinc with HCl. And iron reacts slowly. Iron is less reactive. Iron is not in the, look at here, iron is aluminium, you get group 3, right? Zinc also a bit more reactive. Iron reacts slowly. That means from metal to metal reactivity changes. Group 1 very violently. Group 2 top violently. Group 3 aluminium react rapidly, not violently. Then zinc, iron reacts slowly. Rapidly, violently, rapidly, slowly. That means the way they react different, no? The way they react different. Violently, rapidly, and slowly. That means from metal to metal, the way they react differs. Rapidly and slowly. And some, they do not react. The other one, if you want to analyze this, do not react. Some metals do not react. You don't need to memorize all 80 metals like this, but at least these few examples you should know. These examples given in your syllabus. There are more than 80 metals. All 80 metals no need to memorize. So metals can be categorized into like 4 groups like this. The way they react with acids, violently, rapidly, slowly, and some they don't react. Which metals do not react? Silver, gold, platinum. Ag silver, Pt platinum, Au gold, even copper. This is bit important. You can put a star. These 4 metals do not react with dilute acids. That means no reaction. That's why we use them as jewelries. Especially silver, gold and platinum. Is that clear? Therefore, silver, platinum and gold. Not only with dilute acid. Silver, platinum, gold, they don't react even with water. They don't react with oxygen. That's why we use them as jewelries. If you want, I'll give a summary also for this. In your short note, you can copy down. Not only with acids, not reacting only with metals, acids can react with the other substances also. Anyone still copying down this? Shall I erase this? Did you underline and highlight this? Acids, you should know the formula. Chemical formula of these three, at least these three acids you should know. What are the other acids we can use in even in the kitchen? Okay, if you want to write that, latecomers, please request the recording, or you have to because the initial part, the explanation you might have missed. What are the other acids we use? CH3COOH. This is called acetic acid. What is this called? Acetic acid. Acetic acid. Or we call it sometimes ethanoic acid. Ethanoic acid. Common name vinegar. Vinegar in the kitchen. But the acid present in your kitchen, vinegar. So vinegar also, when you are putting into aluminium pan, it is dangerous. Imagine you are going to make ambulti alma algo, chutney or something in aluminium cooking pot. Aluminium pot. Aluminium pot you are putting vinegar or making achar or something. That is so dangerous. Aluminium will dissolve in vinegar and it can cause aluminium food poisoning. Therefore, you have to make your housemaid or the mother aware of this, not to prepare acidic food in not only aluminium, even iron or steel. Stainless steel okay, the stainless steel okay, but aluminium and iron or the steel, you should not touch or something we call it. Right, aluminium containers, even plates, aluminium plate. So you should not do this. Some of use nambilia and all this like koraha, different terms they use in the rural areas. This koraha, nambilia. So some of them metal, made of metal. You have to be very careful. Not only that, some of them they are not aware of this. Have you all? I don't know whether you have noticed this. This is also like actually the kitchen is like a chemistry lab, right? You can learn a lot of chemistry from your kitchen, and health issues associated with your bad practice of these things in the kitchen. Shall I read this one? Did you all finish copying down the note? Anyone still copying down this? Please raise the hand. Anyone still copying down? Please raise the hand. When you're done, please lower your hand. Okay, Nilakshi, hurry up. Now, the other most important thing I wanted to tell, not adding vinegar into the aluminium pot for making food. Have you seen after making this, what is this called, pappadam and all, oil? Or you fry something, maybe rolls or cutlet or something, after making roll or cutlet or pappadam, what happened? They take again a container and they put here newspaper. Newspaper or paper. They take a piece of paper from the newspaper and put here whatever the rolls or cutlet here. What happened now? Or pappadam. Because oil drains. Is that good? Now, ink present in ink cancerous. Ink present in your, please make your mother aware of these things. Ink present in these newspapers cancerous. Cancerous, carcinogenic. Cancer causing agents are there. Carcinogenic. What happened? Oil gets soaked to the paper, at the same time ink gets soaked to the cutlet and the pappada or whatever the roll. Then you are eating, so no wonder you will get cancers. Cancer patients increase in our country. That is, so that means scientific knowledge, scientific literacy important in the kitchen. So don't make them aware of this, not to put into the newspaper after frying food or anything into this one. Now even the top like like KFC, McDonald's, they use papers but without ink. Have you observed innermost surface is like very clear, not printed. Innermost surface not printed when you buy food from any food canned food. And the other most important thing, not only that, if you go to the fish stall, shall I erase Nilakshi and all? We are done, right? Okay, I'll erase this. This is like sometimes we don't pay much attention, but actually so dangerous to do this stuff. When you go to the fish stall, I'll tell one more thing. This ink contains a lot of harmful chemicals. Nowadays you don't buy newspapers because of COVID situation, the contact. I'll give this is the other. If you go to the fish stall, fish market, what happened? The fish stall, they have the fish here, right? So after when you get the fish from the market, they weigh from the balance. They weigh this from the balance, and then they have a piece of this on paper here, and put this fish after weighing, put this fish into a paper. That's how they do. Newspaper again, and weigh the fish, and then they take a shopping bag and put this. What happened now? Ink. Okay, most dangerous thing is this. They cut this like tuna, kelavalla, balamalu and all that. They cut into pieces. They cut this into pieces, and they wrap this. They put this into a newspaper, right? They put this into a newspaper. What happened? Ink present in the newspaper gets soaked to the fish. The most dangerous things, you cut this into pieces. If you buy a big one, so they will cut into pieces, not a small one like the spreads and all. That also not good. Then ink present in the newspaper gets soaked to the those pieces of the fish, right? That is dangerous. So it's cancerous, right? You are bringing all the cancerous chemicals. You are cooking food. That is so dangerous. By heating, you can't destroy these chemicals, right? So that is important. There are so many other stuff concerned with this preparation of food. Therefore, some people they complain, we never smoke, we are eating healthy food from the market, but at the end they can get a cancer because of this bad practice of this, right? So tell them not to wrap. So just ask them to put into the shopping bag, not to put a newspaper because people can see the fish in the shopping bag is transparent or translucent. Therefore, they cover that with the newspaper, the fish. That's what they do. Even when you buy, the other most interesting thing this, the festival season. Kavum kokis dodol. Again, what happened? Is oily. They soak this into a newspaper. Like they take a piece of paper, printed paper. They put dodol kavum kokis, and then what happened? The oil gets soaked to the paper. Printed paper, and oil gets soaked to the paper, and ink gets soaked to the kavum. Ink gets soaked to the dodol. That is also dangerous, because some of the heavy metals dissolve in fat, lipid soluble chemicals are there. Organic compounds, carcinogenic organic substances easily dissolve in fat or lipid soluble one, right? So that is also very important. That's why I want to tell these reactions of chemical reactions take place. Even reactions can take place there. This summary also you better copy down. Reactions of metal acid reactions, right? If you take acids, say example, say HCl acid. This HCl, if you put into a metal, not all the metals, some metals, like if you put into metal, what is the gas given out? With metals it react and release hydrogen gas. And the other important thing, if you put this into a acid, if you put into carbonate, what is carbonate? Say calcium carbonate. What is the gas given out? CO2 gas. Copy down this in a short notebook. Chemical reactions of acids. Carbonate, example calcium carbonate. Metals, example zinc. Please write down. So I'll put this way, then it's easy. With acids with metals. Example zinc, magnesium. What is the gas given out? Hydrogen gas. Then acids with carbonate. Example calcium carbonate. Within bracket. What is the gas given out? CO2 gas. This is not given in your textbook. This is for your information, because this lesson you need, because last part we are discussing about the preparation of gases. If you put acids into bicarbonate, what is bicarbonate? Baking soda. You can make a volcano, like, magic experiment. Sometimes some universities, when I was in the university, Colombo University, chemistry department, we had a chemical society, right? University chemical society. We had a chemical society. So chemical society, what happened to raise funds? So what we are doing, we are visiting. So sometimes you have a science day in your school. The school science day, they invite us to do chemistry magic shows. What is that called? You can search, even now also they have this Colombo University chemistry magic shows. What is the best university in Sri Lanka? What is the best university? What is the ranking number one in the ranking number one? Which university? Colombo. For science, number one, Colombo. Colombo Medical Faculty, science. Okay, it's like if you take commerce and all, Javadanpura and all. So chemistry magic shows. So then the students are very much interested about this chemistry. They like this chemistry magic shows. So science day from the university, they invite chemistry department university to do the chemistry magic shows. So they use this volcano and different things. I don't have time to tell those. You can search even in the internet. Students are very much interested about this. They fire without getting burned, different so that is also very interesting, right? So therefore, that's why all these chemical reactions can be used for the chemistry magic shows also. Okay, therefore that's bicarbonating. Any bicarbonate. Carbonate means what? CO3 2 minus. Carbonate means any compound with CO3 2 minus. It can be calcium carbonate, copper carbonate, iron carbonate, aluminum carbonate, sodium carbonate, right? Any carbonate, right? Not only calcium carbonate, sodium carbonate also can be, right? Any carbonate, calcium carbonate, sodium carbonate, lithium carbonate, copper carbonate, any carbonate with acid. What is the gas given out? Carbon dioxide gas. And metals, if any metal react with acid, so HCl, so hydrogen gas is given out, because HCl contain H, right? H2 gas is given out. That is a single displacement reaction. Then bicarbonate. With bicarbonate, this also we can use to prepare carbon dioxide. Example, you can write bicarbonate means HCO3 minus. HCO3 minus. So if I give the compound here, sodium bicarbonate, we call it baking soda. What is sodium bicarbonate? Baking soda. This baking soda or baking powder, sometimes we call it apple soda. What is the gas given out? CO2 gas. CO2 gas is released. Therefore, both carbonate and bicarbonate can be used to prepare CO2 gas in the laboratory. So I told you now, now you are doing how many subjects? 9 subjects. 9 subjects. So A level, it becomes 3 subjects. University, you can do 1 subject if you want. You can do chemistry special degree. 1 subject you can select. The most interested subject. Okay, 9 subject become 3 subject. 3 subject become 1 subject. And 1 subject also you can do about, okay, say one example, you can do about, you can do a master or PhD about, say, water, or say nanoscience, so maybe analytical chemistry, or protein, or pharmaceutical chemistry, computational chemistry. Chemistry itself has lot of areas, right? Computational chemistry, you can design drugs using computer model. Computational chemistry. Pharmaceutical chemistry, right? That you can get specialized. Not entire chemistry also vast area. And it's like, can you see, now this is what you should focus. Now you are grade 11 now. For this year you will be promoted to grade 11, then you should be fully focused. So sometimes what happened, you don't like science, but within science you have what? Chemistry, biology, physics. That also you can filter, right? 9 subjects become A level 3 subjects, 3 main subjects for the university entrance. So out of these 3 subjects also you select, say, chemistry for your special degree. for your higher studies. And under chemistry also you can do a PhD or master about computational chemistry or analytical chemistry or organic chemistry or polymer science, polymer chemistry, right? That. So therefore it's electrochemistry, like that. There are different branches. Now, and the other most important thing, you should get selected to the best university. That also important. Example, for medicine, Colombo. For science, Colombo. Like some university for dental, vet, agri, Peradenian. So anyway, you can when you are doing so you now for the school, what happened? You are targeting the best school after your O-level results, after O-level or after scholarship. You are targeting the best school in the country. Parents are struggling to put you to the best school, right? The best school in your area. From O-level results, from grade, if you can't enter from grade 1, at least you target from a scholarship grade 5. If you can't enter the good school from scholarship, at least for after O-level, right? After O-level, there are three options: from grade 1 or from in between. Also you can go scholarship, or after O-level results you can join a good school. Then after A-level results, what you are targeting the best university. You should target the best university in the country, right? So example for science is Colombo, best university, ranking, South Asian ranking within first 10, or Sri Lankan university ranking system #1 Colombo, the best university, like that. So then only when you pass out from the university and when you are going for an interview for a job, but they will ask from which university. For that you get more points. You understand what I'm saying? If you are telling I am from this school, so it's some points added for that, right? And from this university, yes, then they will ask the university after obtaining the degree before the school. So those things, even if you are doing a private degree, you should have to be you have to check in the internet world ranking, what is the position of that university, right? So you should be aware, because parents they will come behind you until your O level. After that they are not paying much attention. Then you should know the rest, right? They can't be behind you every day. Then okay, I told now these three. There are some other reactions of metals also, but at least these three you should know. At least these three you should know, right? In addition to that, metals can react with. Then I'll put one more. I told now carbonate, bicarbonate, with metals, with carbonate, with bicarbonate, right? If you put acid into a right, one more example. Quickly copy down this in your short notebook, not in the theory dude. Everyone should maintain a chemistry short notebook. Chemistry short notes. You can add this, then it's easy to remember, because we have the gas preparation in the last part. All three gases you are preparing. For the preparation of all three gases, you need what? Hydrogen, oxygen. Oxygen I have not given here. Oxygen I have not given here. Then the other one I'll write, add one more I'll write with bases. Acid react with bases. Alkali. Bases. Example, sodium hydroxide. Sodium hydroxide. Any hydroxides. Any hydroxide react with acids, producing what? Salt and water. Salt and water. Salt and water. That is called neutralization reaction. That is called neutralization reaction. Acid react with, you can see the screen, right? Bases, so sodium hydroxide, potassium hydroxide, calcium hydroxide, any hydroxide. Sometimes we call this reaction is known as neutralization reaction. This reaction is known as neutralization reaction. If I add, I'll write here with metals, with carbonate. You can add the word with here, with bicarbonate, here with bases. The product I have highlighted green, and the reactant pink, and the other reactant acid. In addition to that, if you only write here, I don't have space here. At least these are. If you take oxides, metal oxides also it react with metal oxides. Metal oxides. Metal oxides. Like example, sodium oxide, calcium oxide. Also acid react. Then you get again sodium chloride, salt and water, salt and water, salt and water with any metal oxide. Metal oxide also it react. Sodium oxide, then you get sodium chloride and water. With calcium oxide and HCl, you get calcium chloride and water. Please copy down that also. Example, metal oxide, sodium oxide, calcium oxide. Right. Anyone still copying down? Please raise the hand. Anyone still copying down? Because you don't have this in your textbook. These are short notes. Until, because you are getting this, you are doing this not only targeting term test, O-level exam, these short notes very important, very important. You don't have this in your textbook. Therefore everyone should maintain the same now chemistry short notes, the same book until your O-level. Grade 10 chemistry and grade 11 chemistry short notes in one book, that is chemistry short note book, summary note. Physics you should do the same thing, and biology also, but mostly the chemistry, my past experience last few years marking, even the students those who get A pass, chemistry part the performance like bit low, the marks, chemistry marks bit lower than the biology and physics, even those who are getting A and B pass. Right, when you are done, please lower your hand. So not I put here the example acid, it doesn't mean only HCl, no, other acid also will react, other acid also will react, other acids also will react. I'll give one example. What is the acid in your stomach? HCl. For gastritis, what you should drink? You have a drink. I'll give one example. If you search, if you can check, I don't know whether you have I have a small kid, I mean, have you ever heard about this gripe water? I don't know whether you have. If you have a baby in your house, gripe water for the babies, they put like gudu seven or something, like for them, like for the bad stomach, they can't give asamodakam and all. For the babies, like 1 or 2 months, gripe water, GRIPE, gripe water. Have you ever checked the ingredients of gripe water? Gripe water contain what? Bicarbonate, sodium bicarbonate. What is present in gripe water? Sodium bicarbonate. Therefore, if someone accidentally drink by mistake an HCl in the laboratory, then you can dissolve some sodium bicarbonate and drink. Please raise the hand those who have heard about gripe water. Gripe water. One day you also was right. You have spent that age, after your birth, within first 6 months, they give only breast milk, right? Mother's milk, so then other than that, sometimes for the babies until about 3-4 years, they give gripe water for the bad stomach. You know this, most of you all heard about gripe water. So if you have a gripe water bottle after the class, check the ingredients. Sodium bicarbonate is there, that is basic, and acid in the stomach can be neutralized. Gripe water. There are many chemicals like this, so therefore for the neutralization of the example for gastritis, please check again Digene. Like you have the Digene, like there are various Gaviscon, pantoprazole, like medicine tablets, pills, Pantodac, omeprazole, esomeprazole, pantoprazole, like various drugs for gastritis. Other than that, you can directly buy from the food city or like pharmacies without doctor's prescription, this Digene or like commercial one, that actually all these contain bases, all these contain basic compounds. So those basic compounds react with acids, and acids get neutralized, so you get gastritis due to the oversecretion of HCl, and that can be neutralized with this, right? So therefore chemistry, biology, physics, so actually chemistry, physics, so it's actually they are very practical subjects, all what you learn related to your daily life. That's why it takes more time for me to teach this, because I am trying my best to relate all what you learn to the day-to-day life or practical applications. then only you remember. Otherwise, what is the point of just only for the exam, only for targeting marks? You are just memorizing and repeat like a parrot. You are repeating that in the exam. After the exam, nothing is here, no science. You might not believe, there are students those who have got 9 A's, A level 3 simple passes bioscience, O level 9 A's, A level 3 simple passes, or sometimes all 3 down, A level maths, physical science. Problem is that they just memorize the note and somehow they manage to get A pass or B pass for science, O level, but A level they don't have that scientific mind or scientific knowledge. Therefore, that's why I'm making this much of effort, not targeting your term test and the oral exam, right? Okay, to improve your scientific knowledge, scientific literacy. At least one day you will tell this info, because after some of you all, you are not doing A level bioscience, you are not doing A level maths, so you will be doing A level arts or commerce. That is the end of your science. Then unless you do a course or separate diploma or something related to science, right? Anyway, I'll stop the screen now. You had enough time to copy down. Anyone still copy down this summary? What is this summary of uh, acids? Reactions of acid reaction summary, acid reaction summary, summary of acid reactions. That you can write the summary, acid reactions or reactions of acids, summary note, right? For your, there are many more reactions, but this is until up to O level, this is more than enough, up to O level, right? Then I'll erase the screen. Let's move back to the theory table. Okay, I explain in detail about what are the acids, where are they found, and what are the different types of acid: concentrated acid, dilute acids, then weak acid, strong acid. If you take like this, vinegar is a weak acid, vinegar weak acid. Okay, acid also you can classify like this. If you want, you can copy down this also. Acids can be categorized like this. That is additional information. If you want, can add this also to your short notebook. Acids can be categorized as weak acids and strong acids. Okay, let me explain that also. I'll write here. Acids can be categorized as weak acid and strong acid. Weak acid and strong acid. Please copy down this also into your short notebook. Acids. What? Weak acid, strong acids. Dilute acids, conc acids. DILUTE, dilute acids and conc acid, concentrated acid. Concentrated acid. Please copy down this short note also in your writing book. Concentrated acid. Concentrated acids. Dilute acids. Weak acids. Acids we can classify like this: weak acids, strong acids, dilute acids, concentrated acid. If you want, I'll give some examples. Acids can be classified like this. Acids. Weak acid, you can write example: vinegar. Acetic acid. What is acetic acid? CH3COOH. It's a weak acid. Strong acid, you can write example: nitric acid, sulfuric acid. Any weak acid, or if weak acid also has, weak acid can have high concentration or low concentration. Strong acid also you can have dilute or concentrated. Okay, so dilute acid, you can, any acid you can have dilute or concentrated. So example, dilute HCl also you can have. I put DIL or D dot. Mostly in the exam they put D dot, DHCl or dilute HCl, or they put DIL, DIL. DIL means diluted HCl. How to dilute? By mixing the. So there is another one called conc acid, conc HCl. So HCl you can have conc HCl as well as dilute HCl. Dilute HCl. Right. Therefore, now okay, wait. I will if you want, I'll write this way also. Then no problem if you have already copied down. So this way also I can write it. acids can be divided as weak acids, weak acids, weak acids and strong acids. Then any weak acid we can divide again into what? Dilute or conc. Dilute or conc. Conc means concentrated. Conc acid or dilute acid. Previous one, if you have already copied down, no need to copy down this, huh? This others, if you only can copy down this also, anyway, in addition to the previous one. Because these things not given in a textbook. Even grade 11 also you have a separate lesson called acid base lesson. Separate lesson, acid base lesson. But even in that lesson they have not, because when you come to the grade 11, because I am not telling anything out of syllabus, all this related to your subject, right? They can test these things in the oral exam. So I am teaching targeting the oral exam, not targeting only your school term test. Acids can be divided as weak acids and strong acid. Any weak acid or strong acid again can be divided as dilute acid or conc acid or concentrated acid. Conc means concentrated dilute acids or diluted acid. And the other one, this also you can write conc dot. Conc means concentrated. If you only write the full name, no problem. Dilute acids. Dilute acid. Dilute acid. Then this way also you can copy down that example. So I'll write example weak acid. You can write what? Example CH3COOH, acetic acid or vinegar. So vinegar we can have what? Conc CH3COOH and dilute CH3COOH. CH3COOH means acetic acid or dilute D dot CH3COOH. The strong acid, if you take, I'll write the example, say HCl. Example HCl, hydrochloric acid. HCl also you can have conc HCl. If you go to the lab, if you ask from your school teacher or lab assistant, can I see the conc HCl? They will show the bottle. Can I have dilute HCl? I put D dot HCl, dilute HCl. So that is also very important. Conc and dilute. So any strong acid or weak acid you can have in the dilute. How to dilute? By mixing with water. More water and less acid, and acid mixed with water diluted. Acid with higher proportion of acid and lower percentage water, then it is conc acid. So acids, you have a separate room, the storeroom acid in your school laboratory. So that contain conc acid. The thick like large bottle, right? Like about 5 liter bottle, or sometimes 2 or 3 liters bottle, glass bottle, brown colored bottle. Brown colored bottle they use acid. That is the stock. That is conc acid. They put conc. Brown bottle. When you open the lid, the fume is coming out. Fume is coming out. Dangerous. Then they put like few milliliters into a beaker and dilute it, or reagent bottle. That's how they prepare dilute acid. So the teacher is preparing the lab assistant making dilute. They convert this conc acid into dilute acid. Sometimes you can use about 5-10 years. They can use this conc acid bottle, 5 liter bottle. So you have a separate in your school laboratory chemistry lab. There's a separate room to store chemicals. So if possible, just there. So they put this on sand, because if acid is spilled, then it's very dangerous. It can cause a fire. Imagine due to floods, your school, the laboratory, if your area is like frequently subjected to floods, so it's dangerous to have the school laboratory in the ground floor. So most of those areas, the science lab or A-level chemistry lab, either second floor or third floor, because having that in the ground floor, it's dangerous if your area is frequently subjected to floods, or even due to less rain, or maybe close to the bank of the river. So when the river overflows, the school get flooded. Then what happened? Acid bottles will start floating. So not only that's the danger, what will happen to the like water pollution, like a lot of severe damage. Right. if your school laboratory also, if the roof is not damaged, the sheets or the tile uh, roof, so then what happened again, acid can contact with those at highly exothermic, most of the reactions with acid, so a large quantity of heat is given out. When acid react with anything, a large quantity of heat is given out. Okay, so please copy down. Anyone still copy down this acid classification, right? What are the other strong acid? You can write here HNO3, H2SO4, sulfuric acid, battery acid, Guinea nitric acid. To make gunpowder, they use HNO3, nitric acid. So these acids, now also one acid is present in your stomach, HCl. If you take your vehicle car battery or motorcycle battery, sulfuric acid is there. Then if you go to the kitchen, vinegar is there. So actually out of these three acids present in your house, your stomach contain HCl, and if you have a motorcycle or three wheel or whatever, the sulfuric acid there in the battery, and vinegar is there in your kitchen, and nitric acid only not available most of the houses, because that is it's illegal to keep nitric acid large bottle. In single we call it Guinea Mathura. It's so dangerous because people, they are terrorists, they use nitric acid to make explosives. Therefore you can't keep nitric acid, you can't transport without permission, right? Without permission is illegal to have large quantity of nitric acid unless for the laboratory purposes or the experimental or the academic work, right? Shall I read this, and did you all finish copying down? Okay, so therefore I am not just teaching the textbook note. Yes, that is a must, that is there in the theory too, the formal note there in the theory too, but this additional information very important to improve your, yeah. Any questions, Sujivani, Sumaila, to ask? Any doubts?
Sir, what are the criteria that should be applied to decide this acid is a weak acid or strong acid?
Yeah, yeah, good question, Sumaila. Now actually that lesson you are doing in grade 11, weak acid. Okay, since you asked that, I'll quickly tell that if you put weak acid into water, if you put an acid into water, if it is separately ionized, I mean if it is fully dissociate into hydrogen ion, and if now this one has hydrogen, any acid release H plus, so if that completely ionized into CH3 COO minus and H plus, like when you take sodium chloride, when you put sodium chloride into water, what happened? It become Na plus and Cl minus. Salt, when you add salt into the curry, or when you add NaCl into water, it separate into Na plus and Cl minus completely. So in the curry, no NaCl, only Na plus and Cl minus. Like that, acid also separate into H plus and an ion or negative ion. It separate into positive ion and negative ion, CH3 COO minus and H plus. But some acids, they don't separate completely like this. Such acids are called weak. But if you put HCl into water, it completely separate into H plus and Cl minus, 100% separate into H plus and Cl minus. That is why we call it a strong acid. If acid completely separate, dissociate into H plus and the positive and the negative ion, it is strong. If acid partially, if you put say 100, around 60 will separate like this. That is then about 40 acetic acid molecule, vinegar molecules remain as the original form. Then it is weak acid. Then it is weak. Strong means completely separate in aqueous medium or in water. So example, if you put HNO3 into water, what happen? It become H plus and NO3 minus completely. None of the molecule remain as HNO3 in water. Everything will separate into H plus and NO3 minus. If you put sulfuric acid into water, what it separate into 2H plus and SO4 minus. You will learn this in grade 11 acid based lesson. There's a separate lesson in grade 11 acid based lesson. There you will be getting a separate note for this. Since you asked that, I told the answer, but no need to copy down that here. Acid and classification, the criteria you will be discussing, but anyway I explained that now, right? Weak means partially separate, strong means fully separate into H. Positive ion means H plus, negative ion means Cl minus or NO3 minus or SO4 2 minus, because you have learned the radicals, chloride, nitrate, NO3 minus and nitrate. HNO3 separate into H plus and NO3 minus. Therefore no HNO3 in water. When you put HNO3 into water, if you put 100 molecules, all 100 become what? 100 H plus and 100 NO3 minus. Then that is why we call it strong acid. Is that clear, Zumaila? Now is that clear? So given also I think the same question I hope you ask. Vinuk, if you have a question to ask. Vinuka, do you have a question? No, right? Okay. Sumela, is that clear? Any more doubt? Sujivani?
No, sir.
Clear,
Right, okay.
sir.
Okay, clear, right, okay. So I will erase this. Anyone still copying down this? Right. Okay, I'll erase the screen. Nisulu, you're copying down? Okay, done, right? Okay, if you want, you can take a screenshot, right? These very useful short notes for your O level, right? You can buy the short notes from the bookshops also, but without understanding, you just memorize the short note if you buy the short notes from the bookshops. Now, actually, short notes, the student should prepare the short note, not the teacher. After finishing the lesson, the students are supposed to prepare the short note by after studying that lesson. But now what happened? This is like the teacher's exam. The teachers are giving the note as well as short note both. But anyway, it's okay because you can't decide this by yourself. You need the teacher's guidance as assistance. I mean, help to make a note like this, like harder subjects. Right. Okay. Then I'll erase the screen. Very useful. These should not. Yeah. Then let's move back to, because acid is a very important topic. Okay. Next one, chemical reactivity of. Next one. Look at this theoretic now. Look at the screen. Chemical reactivity of metals with the other solutions of metals. Other solutions of metals. That means metal is zinc. Metal of the other solution. This is the solution of metal. Okay, I'll encircle this with the this one. Solution of metal is this. Metal is this. Metal with the other solutions of metal. What is copper is the metal. Solution of the copper is copper sulfate. That also there can be a reaction, but not always. It depends on the situation. Let's see what happens now. You have learned before single displacement reaction. You have learned single displacement reaction. So actually what has happened here, zinc is more reactive. Zinc come and displace copper out. Copper out. Copper has to leave by giving the position to zinc. Then it forms zinc sulfate and copper. If you want, you can write here copper sulfate solution is blue. Okay, please write under copper sulfate is it's blue. Copper sulfate is aqueous, AQ. AQ. Zinc sulfate colorless. Colorless. Then copper, it's reddish brown. Reddish brown copper. Reddish brown copper. So what are these? Reddish brown copper, colorless zinc sulfate and blue. So what happened? Blue solution become pale or colorless. If copper completely displaced out by zinc, blue solution become colorless or it's get decolorized. One observation, right? Under observation, right? One observation, blue solution become pale or colorless. Or colorless. Number one. Second observation, you can write zinc rod or zinc plate or zinc rod gradually dissolves. Gradually dissolves. Then third one, zinc plate dissolve and reddish brown copper deposit. Reddish brown copper deposits or precipitate. Precipitate means a solid will precipitate. Precipitate is forming. So these are the three observations. Initially the solution is blue because of copper sulfate. Now later it's not copper sulfate. it becomes zinc sulfate. Copper sulfate has become zinc sulfate. Zinc sulfate is not blue. Right? So actually what happened, copper will be deposited here. Copper will deposit at the bottom and zinc rod gradually corrode. Zinc rod gradually corrode. Wait, I will write here now. Actually, what happens here? Zinc lose electron and become Zn2 plus. Zinc lose electron and become Zn2 plus. This is one reaction, and the electrons lost by zinc gained by copper. This is actually what happens here. One metal lose electron, the other metal gain electron. Who lose electron? The most reactive metal. Most reactive metal lose electron. I'll highlight that green. Zinc lose electron, electrons lost by zinc gained by copper. These are the two. Actually, this is what happened there. Cu2 plus copper, it gained those electrons and become Cu. If you want to write that, zinc lose electron, copper gain electron. Copper available what? Copper sulfate solution contain what? When you put into water, it is not copper sulfate. It becomes Cu2 plus. The solution contains Cu2 plus and SO4 2 minus. Right? No more copper sulfate in water. In aqueous medium, when you dissolve these blue crystals in water, it become Cu2 plus and SO4 2 minus. What happened to Cu2 plus? Cu2 plus gain electrons. 2 plus get cancelled by 2 minus. 2 electron means 2 negative charges. 2 plus and 2 electron, the charge becomes 0. Then is pure copper is forming, that is reddish brown. That's how you get this copper, the product. Then Zn2 plus combined with the sulfate ion available in the solution. Zn2 plus combined with sulfate and form zinc sulfate. Here 2 plus and 2 minus nicely balanced. Here 2 electrons get added. That's how you get the products. So this is actually what happens. Zinc atoms of the zinc rod. Look at the diagram again. Zinc atoms, this might contain billions of zinc atoms. If you take a zinc plate, it contains billions. This reaction is not taking place only once. We write the reaction only once, but it doesn't mean this reaction is taking place only once in this solution. This same reaction could occur billion times in this, because if you take like few grams, it contain like Avogadro constant, like you will get large number of zinc atoms. So gradually zinc atoms of the zinc rod jump to the solution as Zn2 plus, leaving electrons on the surface. So those electrons won't travel through the solution. Electrons are deposited on the surface of the zinc rod. Those electrons are gained by whom? Copper ions in the solution. Cu2 plus ions in the solution gain those electrons from the surface of the zinc rod. From the surface of the zinc rod, zinc atoms jump to the solution as Zn2 plus by depositing electrons on the surface of the zinc rod. Those electrons are gained by copper ions. One person lose electron, the other guy gain electron. One lose electron, the other one. That means electron loss and gain balance. Here look at this. 2 electrons loss and those 2 electrons gain. Therefore electrons are not wasted here. Right? Therefore, during a chemical reaction, which subatomic particle involved? Electron. In chemical reaction, with not protons, not neutrons. That is only nuclear reaction. In chemical reaction, which subatomic particle participate in not only reaction, even in chemical bonding? Who will participate for this? Electron. Outermost electron. Zinc atom, outermost electron loss, and those electrons are gained by copper. Actually, for this to happen, zinc must be more reactive. Why this reaction take place? Zinc is more reactive than copper. Otherwise, zinc can't displace copper out. Copper will tell, I am more stronger than you. You can't leave me. You can't send me out. You understand what I'm saying? For the zinc, what is this reaction called? You have learned what is this reaction called? Single displacement reaction. You have learned this at the beginning of this lesson. At the beginning of the lesson, you have learned four different type of reactions: single, double, then decomposition and combination. This reaction, if you want to write about this, single displacement reaction. What is this reaction? Single displacement reaction. This reaction is very important. Oral paper once they ask this, because observation, there are so many things they can ask here. Type of reaction, then observations, balancing of equation, a lot of things they can ask. Single displacement reaction. Now if you want, you can put a stand, right? For the single displacement reaction to take place, the metal added must be more reactive. Again I'll repeat, write with the red pen. For the single displacement reaction to take place, the metal added should be more reactive than the one in the solution. If you want, you can put a stand, write it. For the reaction to take place, for the single displacement reaction to take place, the metal added should be more reactive. Please write it. I don't have space to write it here. Are you all writing? Somewhere right here. Metal added should be what? More reactive. Metal added should be more reactive than the one in the solution. For single displacement to take place, for single displacement reaction to take place, what is the requirement? Metal added should be more reactive. That's very important. Zinc is more reactive. What happens if you do this the other way around? Look at here, look at this screen. If you put here copper into zinc sulfate, nothing will happen. Copper, I have given that at the bottom. Copper into zinc sulfate, copper can't displace zinc out. Zinc will tell, I am strong, I am more powerful, therefore you can't send me out, you have to stay alone, right? But when you put zinc into copper sulfate, copper will tell, you are more stronger than me, therefore I am leaving. You will go with sulfate, you will combine with sulfate. Do you understand what I'm saying now? Right. Any question? I think Sumela raised the hand. Sumela, any question, any doubt?
Yes, sir. In here, copper gains 2 electrons, no, but in usually metallic elements releases electrons, no. So it can't be releasing electrons.
Yeah. Good that you asked. Okay, it's like this, Sumela. Now, copper is not a pure metal. Copper is our iron, right? Metal ions can gain electron. Since you asked that, now neutral metal ions only lose electron. Shall I read this? I'll explain that in the separate. Anyone still copying down this? Please raise the hand. I'll explain that. I had to use the white background to explain the answer for that his question clearly. Anyone still copying down this? Right, I'll read this. Oh, he asked the question, sir, metals lose only electron. How can metals gain electron? Not the pure metal, not the neutral metal atom, Sumela. Metal ion can gain electron. Look at the screen. Okay, wait. Good question you asked. So others also can learn something new from this. Okay, look at this. If you take sodium, okay, neutral metal atom. What is this? Neutral metal atoms. Neutral means they are uncharged. Neutral metal atoms means uncharged. Uncharged ones never gain electrons. Good. Yeah, that what you ask is correct. Neutral. I will highlight neutral one or uncharged one. They will never gain electron. They always lose. Sodium become Na plus. First ionization energy we have learned. Iron become Fe2 plus. Right? They will never gain electron. 2 electrons are lost. Copper lose 2 electrons and become Cu2 plus, right? Cu2 plus, like that. Zinc also can lose copper. Actually very rarely it's become Cu2 plus because copper is less reactive. I'll write here zinc become Zn2 plus 2 electron, or magnesium group 2 become Mg2 plus. So they always lose electron. We call it oxidation. But if it is metal ions, look at Sumela, metal ions, metal ion, not IRON, IONs, metal ions can gain electrons, can gain as well as can lose, can gain or lose electron, can gain or can lose electron, gain or lose both possible. Metal ions can gain or can lose electrons. I'll give example. Look at the screen. This is the example. Metal ions Okay, say Cu2 plus, Cu2 plus like silver, gold, platinum. Okay, this is like this. Silver, they like to stay in the pure form than metal iron because they are less reactive. They are less reactive. They like to gain one electron. They will to cancel this. They have to cancel plus charge. You need a minus charge. To cancel this plus charge, you need a minus charge. Minus charge means electron is negative. Electron is negative. Then it become Ag, right? Or else if you take Cu2 plus, Cu2 plus, Cu2 plus can gain 2 electrons and become Cu. Therefore, metal ions, again I'll highlight here, metal ions, not pure metal, can gain electron. Neutral metal always lose electron. Not only neutral metal, sometimes neutral metal as well as metal ion also can lose. I'll give one example. Fe2 plus, Fe2 plus can lose electron further and become Fe3 plus. That is called, this is ferrous. Fe2 plus is ferrous. Fe3 plus is ferric. So therefore, some metals can again and again they lose electron. This is ferrous, Ferrous, ferrous. This is ferric, Ferric, ferric. Fe2 plus can become Fe3 plus, right? So therefore, it's very, like chemistry, like kind of a, I mean, the we are not actually, we are doing like the chemistry alphabet in O level, grade 10, right? So there's a lot to do. Beyond this also there are some reactions. So these called oxidation reduction reaction. So these left side ones, we give a name called oxidation reactions. This side, these type of reaction lose enough electrons. If electrons are lost, such reactions are called oxidation reaction. Actually, you learn only 4 types, single, double, combination and decomposition. Actually, there are many more reaction type: neutralization, oxidation. You will learn this. This also not out of syllabus. Grade 11 you have oxidation reduction. Oxidation means losing of electron. This is called reduction reaction. Gaining of electrons, such reactions are called reduction, because you can't classify these reactions as single, double, low. This is oxidation reduction process. When you combine this, it become a redox reaction. When you combine this, it become a redox reaction. Redox, reduction oxidation process, right? Is that clear? So Mela, did you get the answer for your question or any more doubts?
Clear, sir.
Right, okay. Please copy down, not only because since he asked that question, the others also can learn something new. Therefore, please copy down this in your short notebook, important for your O-level chemistry questions. Uncharged neutral atom or uncharged can lose electron. Can lose electron. Uncharged metal, neutral metal atom or uncharged metal can lose electrons. Then metal ions can gain, can receive electrons, so as well as can lose. What is the can lose? Metal ions, can a metal ion lose electron? Yes. Fe, now losing also, I'll give example. Ferrous, Fe2 plus, it can become ferric. Ferric to ferrous also possible. Fe2 plus can become Fe3 plus as well as Fe3 plus can become Fe2 plus, both possible, right? This is sorry, this is gaining, no? So this is the other way around. Sorry, this Fe3 plus, I'll write there this Fe3 plus to become Fe2 plus. That's possible like that. Yeah, there can be so that's why I told metal ions mostly gain, but rarely mostly gain. Now mostly they gain electron, metal ions, but they can lose also electron. There are instances like Fe3 plus become Fe2 plus. To become 2 plus, 1 electron should be gained. Fe3 plus, if Fe3 plus gain 1 electron, it become Fe2 plus. If Fe2 plus again gain electron, it become, yeah, that is gaining electron. 2 electrons gain, it become neutral. Therefore, if you want, you can convert metal into positive as well as positive metal into neutral. Do you understand what I'm saying? Neutral metal can become positive as well as positive metal can become neutral. So it's why, like, you can go both the, like, either side. Right. So please copy down this also. Nisula, any question to ask?
So is there any single term for exothermic and endothermic reactions?
Exothermic reactions and endothermic reaction, we call it energetic. So enthalpy, as actually beyond your O level syllabus. Yeah, thermodynamics, thermochemistry, you get different terms there and different meaning. But exothermic and endothermic also two different type of reaction. It's based on the heat change. Exothermic and endothermic based on the heat change. We can't give a single term for that. Yeah. Exothermic means heat is releasing. Heat releasing reactions, exothermic. Heat absorbing reaction, endothermic. Endo means heat in. Exo means heat out. So during some reactions heat is released, that is exothermic. During some reactions heat is absorbed, that is endothermic. That is based on the heat change. Based on the heat change, the chemical reactions can be classified into two. This one we call it oxidation. Now because this one we can combine, who asked that, Nisula, no? These two, 1 and 2, you can combine, Nisula, because only oxidation not possible. If someone lose electron, there must be someone to gain, but exothermic and endothermic can happen alone. Only oxidation not possible. If someone lose electron, there must be someone to gain electron. That's why we call it redox. Reduction oxidation is a simultaneous process. Losing and gaining simultaneous. Now imagine you have an iron chair in your house. Okay, you are sitting on an iron chair. I'll give a simple example. Can iron just dump electron to the surrounding? You sit on an iron chair, metal chair, right? You sit on a metal chair. Look at the screen, metal chair. Now what happened? This metal, the leg of the chair, can this lose just electron to the surrounding? Metal lose electron. Pure metal, I told, can lose electron. Electrons are lost by the iron chair. Then what happened? You are in a pool of electron. You get electrocuted. You will die. Right? That won't happen. Iron will lose electron if there's someone to gain it. Otherwise, the metals, then you will be in a pool of electron in air. If metals are just dumping electron to the surrounding, metals are not just dumping electron to the surrounding. There must be someone to receive it. That's why I told oxidation and reduction is a simultaneous process. Only oxidation not possible, only reduction not possible. If there's an oxidation, there must be a reduction. If there's a reduction, there must be oxidation. Electron loss and gain must be balanced. Understood? Right. Then shall I erase the screen? Anyone still copying down this? Yeah, good. When you ask questions, you will get better knowledge. Like you will gather more knowledge. Good. Right. Shall I erase the screen? Anyone still copying down? Please raise the hand. Done, right? Okay. Because I had to finish the lesson also. I gave detailed explanation because now then you will be perfectly okay. So no need to ask anything else again. You don't need to ask this again from anyone because you have 100% perfect. Beyond that also you have some extra knowledge also. If you are doing A-level science related subjects, chemistry, you will perform very well than the other students, those who have got 9s. You will definitely understand that one day, and you will remember me one day when if you are doing A-level. Sir Jagat sir gave some extra knowledge chemistry, Jagat sir gave some extra knowledge physics. Now we can understand this easily, right? A-level teachers, they are not explaining like the same thing again and again because huge syllabus, right? Anyway, then conclusion is what? Conclusion is zinc is more reactive than copper. Zinc is more reactive than copper. More reactive than copper. Therefore, zinc can displace copper. Zinc is more reactive than copper. Copper, if you want to write the symbol here, Cu. C capital U simple. Zinc is more reactive than copper. That's why the reaction take place. But this one, what happened? You can write this, okay. Now the opposite. Zinc sulfate, earlier copper sulfate, now zinc sulfate, and copper is added. You can write the reaction. Don't write this reaction. Huh? If someone write the reaction, okay, copper can come and displace zinc out. Then you will write what? Copper goes with sulfate, Cu2 plus NSO4 2 minus, and zinc has to go alone. You can write the reaction, but this will not happen. Reaction, a nice reaction is balanced and everything perfect, and you can name this as single. Don't write this reaction. This reaction is wrong. Don't write this reaction. You can write the reaction, but this is what actually what happened. First, we should check whether the reaction is taking place or not. If the reaction is not taking place, we can't just write using the symbol. Using symbols, you can do magic, but that should happen in the nature, in the practical, in the real life. If it is not going to happen in the real life, you should not write it. Practically what happens, scientists, they check whether that reaction take place, what type of products, under which condition that take place. That is like, for about like 200, 300, like more than that, hundreds of years they keep on doing the research and experimental evidences and all. Writing a reaction is not that easy. They can't just write the products. They should check whether actually these products are forming in the real life, in the practical situation. Then only you can write it. But you like just look at the textbook and write the reaction. You never check, no, okay, whether this, I want to see all the products of this reaction. You never ask from the school teacher, right? Since it is given in the textbook, you also memorize. But practically, it's not that easy to write a reaction, right? Since the reaction is given, you write it and memorize and remember and repeat that in the exam. But it's not that easy if you are going to find a new reaction. You find a new reaction. It's not that easy to write the chemical equation or balanced chemical equation without knowing the products. So therefore, this reaction is completely wrong. This cannot happen because copper is less reactive. Therefore, it cannot displace zinc out. Single displacement will not take place. Remember that. Therefore, no observation. Here, no observation. No observation. No reaction take place. Write the reason also. Write everyone. This reaction does not take place. Does not take place. If you want to write the reaction, write does not take place because zinc is because copper is less reactive than because copper is less reactive than zinc. Copper is less reactive than zinc. Now you will ask a question from me. So how do you know whether it's less reactive or more reactive? That is the next question come to your head. Before you raise the hand, I told the question that will come to your mind. How do we know which metal is more reactive, which metal is less reactive when you are mixing like this? Because copper is less reactive than zinc. Therefore, copper cannot displace zinc. Therefore, copper cannot displace zinc. Copper cannot displace zinc. Copper cannot displace zinc. Right. Now, how do we know whether it's more reactive or less reactive? Next page you have the solution. That is called activity series. Right? We'll come to that. They have arranged all by studying all these reactions. Otherwise, if you are going to do this in the school to arrange all the metals in the highest reactive to most reactive to least reactive, it will take more than 1 month, one by one, and some metals not available in your school laboratory. Some solutions, compounds not available. So you will find it difficult. Therefore, they have given that. If you want, you can test that. Any pair of metal you can test and do it. You will get the results. So that next page, the solution is there. Activity series, page number 5 top. Is that clear now? No, does not take place. Reaction does not occur. No single displacement here. Write it. If you want to write the reaction with the pencil, write reaction does not take place. Why? Copper cannot displace zinc out. No single displacement. Therefore, what is the requirement here? You can, if you want, you can put a stand right with the red pen. Therefore, for the single displacement to take place, the metal added must be more reactive. If the metal added is less reactive, no reaction. If the metal added is less reactive, no reaction take place. No reaction take place. Not only copper, you can put silver, platinum rod, gold plate, Au. If you add silver, gold, platinum, no such reactions. Ag silver, platinum Pt, gold Au, same as copper. No reaction. There are so many metals. Okay, I'll ask a simple question. If I put piece of sodium here, will the reaction take place? Will sodium come and displace zinc out? Please raise the hand if you are saying yes. Zinc is group 1. Zinc is group 1 top. If I put a piece of zinc here, sodium or potassium, I put piece of sodium or potassium. Will the zinc going out and you get potassium sulfate or sodium sulfate? Will the zinc get displaced, and if you put a piece of zinc, sodium become Na2SO4 and zinc get displaced because sodium is more reactive than zinc. Sodium is group 1 metal. Please raise the hand. Those saying yes, agree with that. Sodium will come and displace zinc out. Single displacement will take place because sodium is more reactive. Please raise the hand. Those are saying yes. Yes, zinc, sodium can displace copper out, or even zinc out, because both zinc and copper sulfate, both zinc sulfate and copper sulfate, zinc and copper can be displaced out by sodium or potassium. They are more reactive. That's a lot. Now I will lower your hands. Now with the reason, any volunteers, if you are against that, no sir, this reaction, sodium, zinc will not get displaced, or copper will not get displaced by sodium if you add a piece of sodium uh, with the reason. Anyone? No reaction will take place. No reaction will take place. Anyone? Reaction take place, but zinc won't get displaced. Zinc will not get displaced because of this reason. Reaction will be there, but zinc won't get displaced. Anyone is telling? Zinc will not get displaced by sodium, but reaction can occur in the solution. Anyone is telling like that? And you have to tell me what is the reaction then. What is that reaction? Anyone? Okay, that is, yes. Can you, yes, Viman sir, what is the reaction?
Potassium is from the first group and it will react vigorously with zinc sulfate.
Then zinc should get displaced. It will not react with zinc sulfate, but some other reaction take place. That's what I was saying. For sodium or if sodium or potassium react with zinc sulfate, zinc should get displaced. That's what I asked earlier. In nearly 20 students raise the hand. Sodium and zinc sulfate react, but I am telling now it does not react. Why? Now tell me the reason. Some other reaction occur in the solution with sodium, not with zinc sulfate. Sanita, thinking. Now you're thinking a minute.
Has different valencies.
No. I'm asking the reaction. Reaction occur with sodium in the solution, but not with the zinc sulfate. What is there in the zinc sulfate solution? Okay, please, who can tell me the zinc sulfate? Not a powder, ne? Zinc sulfate is not a powder. Zinc sulfate and copper sulfate, aqueous solution. Aqueous means it contain what? Right? Water. You dissolve zinc sulfate powder or copper sulfate powder in water. That is aqueous solution. Then what will happen? Now at least can you guess what would happen when you put piece of sodium into aqueous copper sulfate or aqueous zinc sulfate? It doesn't react with the zinc sulfate or copper sulfate. Then what will happen? Zinc react with sodium react with whom? Sumela?
Sodium react with first of all in water.
Yes, exactly. That's what I was expecting the answer. Sodium react with water violently and become sodium hydroxide and hydrogen gas. This reaction occurs before sodium displace zinc. Sodium react with water. Now that is what I wanted to get from your the answer. But anyway, it's okay, because it's like that won't come to your head because you think only zinc sulfate. No, this is not only zinc sulfate. Water is there in the medium, plenty of water, because you prepare the solution by dissolving zinc sulfate in water. Before it react with zinc sulfate, it react with water and sodium finish. Sodium vanish with water. Write it, right? This is not given in your textbook. Oral paper they can ask, right? If sodium is added to copper sulfate solution or zinc sulfate solution, it reacts with water and get used up before the single displacement. Therefore, highly reactive metals also single displacement that won't happen because they react with water before that. Moderately reactive metal can. Highly reactive, imagine you have a bodyguard. You want to protect for your safety, you keep a bodyguard. That bodyguard is very violent, very aggressive, very violent, always waiting to fight with someone. Then before that bodyguard protects you, he will fight with the other people on the road and get killed by the other people, right? You understand what I'm saying? Bodyguard should not be very violent and very getting annoyed always. That bodyguard, that is not a good bodyguard or security, because he will fight with the other people going on the road, and they will always, he is waiting to have a fight with someone. Then he will get destroyed by the other people before he protects you, right? Bodyguard should wait someone until someone, like, in case of emergency, he should act. Otherwise he has to wait with the weapon. If he, just because of the weapon in the hand, if he is shooting everyone, what happened? Then the other people will come and kill him. You understand? Sodium is also like that. Sodium getting destroyed by himself, because sodium very violently, not like zinc magnesium. You understand now what I'm saying now, right? Okay. Okay, so that is like the bodyguard, violent bodyguard. I'll erase the screen now. Did you all copy down everything what I explained? Right. If not, please request the recording after the class. Next one, activity. This is the answer. Sometimes you can ask, how do we know which metal is more reactive? Out of more than 80 metals, these 14 metals you have to remember in the correct order. Otherwise, you are in trouble. O-level paper. Put 5 stars with the red pen after the periodic table. The second most important list that you should copy down, that you should memorize or remember is this. Periodic table, you have to remember. After the periodic table in chemistry, the second most important one is this. These 14 metals you have to remember. What is this? Descending order of reactivity. Most reactive to least reactive. What is this? Potassium, right? Most reactive. Most reactive. And at the bottom you have, I think, gold. It is least reactive. Least reactive. Why this activity series? Not only to compare the chemical reactivity of metals, not only to I highlight here descend in order of react. Descending means highest to lowest. Descend in order of reactivity means highest to lowest. Highest to lowest. You arrange them in the correct order. How? Not like magic. Scientists, they have done so many experiments with all these metals, and they have, from the experimental results, they have arranged them in the correct order. So this is given. You don't need to check all these metals in the explore. This is how they, the highest reactive group 1 bottom potassium, because rubidium, cesium, francium not there in your syllabus. Group 1 bottom highest, least reactive silver, gold, platinum, but anyway the atomic number, the configuration, they don't ask silver, gold, platinum. Even lead, tin, iron, only up to calcium you have to remember the configuration and atomic number and the charge. Others they don't ask. Charge sometimes you need, right? Now what one benefit of this, the most reactive metals, now metals you have to extract. You can't just dig the earth and get calcium rod. Can you just dig the earth and get aluminium rod? Can you dig the earth and get iron pole? Can't. You have to extract, because they are not available in pure form. Highlight most reactive metals. Electrolysis we are doing in the electrochemistry grade 11. The method is electrolysis for the extraction of group 1 and group 2 metals. But group 1 and group 2 metals, even group 3, group 1, group 2, and even aluminium group 3, extracted by electrolysis. If you can put a curly bracket like this, until aluminium, it's extracted by electrolysis. The most reactive metal, we use electrolysis method. Then this part, thermal reduction with coke or carbon monoxide until lead. Thermal reaction with coke or carbon, this is called thermal reduction, the technique. Method of extracting metals, method of obtaining the pure metal from the compound, method of obtaining pure metal from the compound. Example, sodium available as sodium chloride, NaCl. So you have to get the pure sodium. Then what is the method used? Electrolysis, that method, industrial method, we are discussing separately grade 11 under electrochemistry chapter 12. Electrolysis, separate topic. Then that is moderate reactive one. Most reactive, underline here, most reactive electrolysis. Most reactive metals electrolysis. I'll use a different color. You also can use 2 different colors for this. I'll use blue, this one. Thermal reduction. The method used is thermal reduction for the moderate reactive ones. This one you have to remember. Moderate reactive ones, like, I told you, like very strong, very powerful, very bodyguard is group 1 and group 2. Then moderately reactive ones like this. Then the least reactive metals at the bottom. Below you have in this table the last 5 metals, that is thermal physical method. By physical method, I'll highlight that green. Physical method, native metals or noble metals like silver, gold, platinum, including copper. So that is how you extract metals based on the position of the activity series. Based on the position of the metal in the activity series. Method of extraction depends on the position of the metal in the activity series. Can you please write it? Please put a star and write it. Method of extraction method of metal extraction depends on the position of the metal in the activity series. Please write. Therefore, activity series is useful to decide the method of extraction of metal. Right? Method of extracting metal. Method of extracting metals. Put rest and write in the red pen. Method of extracting metal. Method of extracting metal depends on the position. Depends on the position of metals in the activity series. Depends on the position of metal in the activity series. Metal in the activity series. That is one very useful, there must be a use of arranging them. If there's no use, no point of making the activity series. Activity series is prepared to make the chemistry easier. Why periodic table is prepared? If we are given all 100, more than 100 elements randomly here and there, what happened? Very difficult to study. You make a table, you make a list to make it easier to study, to make it easier to understand, to make it easier to remember, to make it easier to study, make it easier to compare them. That's why you arrange this. Therefore, some students, what happen? They are trying to do answer chemistry hard questions without studying periodic table and the activity series, because activity series or periodic table is not given with the paper. You have to remember that. A-level paper they give. A-level paper they give the periodic table, both part 1 and part 2 chemistry. A-level chemistry, and in the future they might consider what is this called, calculators. Now A-level accounting paper, calculators are allowed. A-level engineering technology subject, calculators are allowed, but not at chemistry. In the future, chemistry also they will allow the calculators. London O-level, periodic table given, calculators are allowed, and the equations also given, physics. London A-level, periodic table given, calculators are allowed, and some equations also they'll give. They don't check much the memory power of the students. They are mostly targeting the evaluation, analysis, thinking ability, like of the students, or the problem solving ability, right? Analytical skills, rather than just recalling the previous memory. Recalling the previous memory now useless. Why? If you data, memorizing data is no more, it's outdated now, memorizing data, because data available in the internet. You search now, current situation in the world, anywhere in the world you can search now, whether it's raining or not, climate, map marking become useless. You can find the distance and whether it's raining, the climate, humidity, everything you can find in Neurelia. From your location to Neurelia, what is the closest path? Neurelia, this maybe this mountain or this place, where it is. Location you can mark your mobile phone, a smartphone. No need to have a big paper like a banner poster and marking the map here, right? That become, in the future those things get updated, like map marking and all become useless in the future with this technology. Now the people, no, about when we were small, like 1980s, 1990s, those who are memorizing the previous data, they are like very bright people, memorizing them, because there's no other storage device to keep them. Not even the CD-ROM. CDs or not, because that floppy disk or something was there when we were small. Now what happened? With nanotechnology, in a needle shape like the space, you can store billions of data, terabyte level in the future with nanoscience. Therefore, vast amount of data you can store, and you can immediately recall that. Okay. Any question, Sumela? Anything?
Yes, in here we have discussed that along the period the reactivity decreases, and down to the group the reactivity increases. So according to that, can't we memorize the activity series?
No, that is periodic table, Sumela, contain both metals and non-metals. Activity series only metals. Only metals. Periodic table contain both metals and non-metals. Remember that. Here hydrogen is here, that is just to compare the reactivity of hydrogen with the other metals. But none of the other non-metals given here. Activity series actually only metals. Down the group in the periodic table, both metals and non-metals, they are group 1 only metals, but hydrogen also there at the top. Across the period reactivity decrease, but non-metals also there. You can't tell across the period reactivity decrease, that is only metals. Across the period non-metals reactivity increase, because both metal and non-metal there. Across the period metal reactivity decrease, but non-metal reactivity increase, Sumela. That's why don't mix up that with the periodic table and these two different things. You can compare with the periodic table also. What? Down the group metal reactivity increase. Across the period, metal reactivity decrease. But that one, you can't compare two different places. Second period and fourth period. Then there's a problem. Down the group also you have to consider. Across the period also you have to consider. Then there will be a confusion. To overcome that, they have put like this. Then no doubt, no, if you take calcium, you can compare with anyone else here. No problem. But if you take calcium and some other metal anywhere else in the periodic table, then it must be confusing. Not in the same row, different row. Right? You understand what I'm saying, right? Then shall I write this animal silk up and down? Again I am telling, if you can write this in a separate paper and paste in front of your studying table, what 14 metals and the periodic table, you have to remember. Without studying this activity series, remember next year, I mean next year means like this year, grade 11, some chemistry lessons you can't understand, right? Especially electrochemistry, and there are some other few more lessons you can't understand without studying the activity series. There are more questions based on the activity series. So then let's see, hydrogen is what? All the metals below hydrogen less reactive than HCl. I mean that they don't react with HCl. Example, earlier also I told you, metals below hydrogen do not react with dilute HCl. Example, if you write here, copper plus dilute HCl, no reaction, no reaction, no reaction, no reaction. Then if you take silver plus HCl, silver plus HCl, dilute HCl, no reaction, no reaction. Please write it. Then platinum plus HCl, platinum plus dilute HCl, PT platinum, PT, platinum PT plus HCl, again no reaction, no reaction. Then gold plus HCl, no reaction, dilute HCl. Even with conch HCl, they don't react silver, platinum, gold, but copper can react slowly. Then metals above, any metal above hydrogen, hydrogen the position important just to check whether it's reacting with HCl or not. Hydrogen the position important just to compare whether it reacts with HCl or not. So if you take sodium with HCl, yes, sodium with HCl, sodium with HCl, you get what? Sodium chloride and hydrogen. Then magnesium with HCl, magnesium chloride and hydrogen, NaCl, MgCl2 and hydrogen. I didn't balance the reaction. Then iron plus HCl, iron chloride and hydrogen gas. They everything above hydrogen react with HCl, because that is why hydrogen is given. Otherwise hydrogen, that's why they have put separately just to compare the reaction with HCl. Otherwise hydrogen is not included in the activity series. Okay, that's why I separately encircle and put an arrow. Activity series consists on only metals. To balance you have to put 2 here, right? 2 HCl, 2 NaCl, here also 2 you have to put because of 2 chlorine, 2 chlorine, this is, yeah, because of 2 hydrogen you have to put 2 HCl. Yeah. Accordingly you have the metal also you have to change. This one is already balanced. Here you have to put 2 sodium, no? Here 2 NaCl and 2 sodium. Yeah. So all these react. Here they don't react, no reaction. No reaction. This one no reaction. Do not react, highlight. Do not react, highlight. Below hydrogen, metals below hydrogen, highlight. What are the 5 metals below hydrogen? Copper, mercury, silver, platinum, gold. Copper, mercury, silver, platinum, gold. Metals below hydrogen. Here metals above hydrogen. Metals above hydrogen react. Metals below hydrogen do not react with HCl. That's very, very important. Sometimes you can get an MCQ in the oral paper. Which of the following metal does not react with HCl? You can get an MCQ. Which of the following metal does not react with HCl? First answer zinc. Second answer iron. Third answer aluminium. Fourth answer copper. Which of the following metal does not react with dilute HCl? What is the answer? Copper. Copper. Like that, they will give 4 other metals with a metal not going to react with HCl or copper, or say they can give silver here. Understand? That is how you get the questions here. They can give 4 answers: zinc, iron, aluminium, copper. which one of these metals not reacting with HCl. So then not only this activity if you remember this activity series, there are many more benefits. What now already I told two benefits of studying this. What one is, you can find the method of extracting metal, method of extracting, which method is more suitable to extract the metal. I told you, like to write down that separately to decide the method of extraction. This helps. Second one, to check whether it react with HCl or not. Then the other uses I have given separately the list. I'll erase. Shall I erase this? Anyone still copying down? Anyone still copying down? Please raise the hand. Right. I'll erase. Oh, Randir, you are copying down. Quickly copy down, or else you take a screenshot, or you can request a recording, no problem. Right. Then uses of activity series. Now method of method of extracting metals, most suitable method to extract metals, highlight. We have already, I explained that already, whether it's electrolysis or whether it's thermal reduction or whether it's to decide whether metal displace. The previous page I told this also. I take previous page bottom. If you want to write here, previous page bottom, previous page bottom, previous page bottom. I explained this, both this I explained. No need to explain again. Why? When you can write here zinc plus, if you want to write example here, okay, wait, I'll write an example here. Zinc plus copper sulfate, yes, copper sulfate, the reaction take place, but copper plus zinc sulfate, no reaction. Copper plus zinc sulfate, no reaction. Here you get zinc sulfate and copper get displaced, right? Therefore, to decide this, you need what? Whether zinc is more reactive or copper is more reactive. Understand? You can write here zinc is more reactive than copper. How do you know? From the activity series. Otherwise, like magic, if I tell zinc is more reactive than copper. Then to select to method to make electrochemical cells, that means batteries, electrochemical cells and batteries. Like, you know, if you take zinc and copper is used to make, I think you had done in grade 9, no? Zinc, like simple cell, zinc and copper. Zinc is more reactive, copper is less reactive, and you connect this with a wire and a lamp bulb, and you can make electrochemical cells. You can put here H2SO4 sulfuric acid, battery acid. So to decide this pair of metals, you can't put here platinum instead of zinc, then it won't happen. One metal should be more reactive, other one metal should be less reactive. Then to make electrodes, what are these called? Electrodes. Electrodes are used in electrochemical cells. To decide this electrode, we use activity series. Then to find a method of preventing corrosion, example galvanizing. Galvanizing, what is used? Zinc is more reactive than iron. Zinc is more reactive than, look at the activity series. Zinc is up top, iron is bottom. Zinc is more reactive than iron. How do you know? Look at the activity series. Zinc is more reactive than iron. Therefore what? Iron can be protected from rusting by using zinc. That method is called galvanizing. Right here, zinc is more reactive than iron. Zinc is Zn, iron is Fe. Zinc is more reactive than iron. Therefore zinc can be used to protect iron from rusting. Zinc can be used to protect iron from rusting. To protect iron from rusting. Iron from rusting. What is this called? Galvanizing. From rusting. If right here within bracket, that method is known as galvanizing. Galvanizing. Have you all heard about this GI tube, GI pipes? Please raise the hand those who have heard about GI pipes. The people, those who rent in that the construction site, like Unabata or something, because instead of that they put GI tubes. Even for the name boards and all, they have a long, like cylindrical, that one, that is, it won't get corroded. Why? This is called what is GI meaning? Galvanized iron. What is called? Galvanized iron. Galvanized iron. GI means galvanized iron. Barbed wires, katukambi, like for the fences, that also what? Galvanized. Galvanized nails won't get rusted. Very good. Galvanized iron tube. Galvanized iron tube. If you use just iron tube, but the steel tube, it will get corroded. Panittua, please raise hand those who have seen the panittua. You are going to the bathroom and open the tap. You might have not seen the panittua. You have the plastic bucket. Panittua. I don't know, panittua, that bucket, like the steel one. The steel, made of steel. Rural areas, to draw water from a well, they use panittua. Those who have, please raise their hand. Those who have ever experienced at least once in your life having a bath using panittua from a well. Drawing water from a well using panittua, that bucket, and having a bath, ever experience in life? In vain otherwise. You should go to some area, rural area, and have fresh water, clean water without chlorine. Have a bath from a well or from a pond using panittua. Panittua, it sink because it's iron, but plastic bucket, very difficult to fill water into the plastic bucket because it floats on water. Right. So that is galvanized. Otherwise, it get corroded. It will undergo rusting. This is also galvanized. Panittua sometimes. Most of this. Right. So now you can understand what is used to protect iron from rusting. Zinc. That method is called galvanizing. How do you know whether zinc is more suitable, or whether aluminium is more suitable, or whether sodium is more suitable? Activity series. Right. Then precautions when storing metals in the laboratory. Example, right? Sodium is stored in oil. Sodium is highly reactive. Sodium is highly reactive, right? Sodium is stored, for the number one right example, sodium is stored in oil, paraffin oil. Stored in paraffin oil because it's highly reactive. The activity series, the ones at the top, stored in paraffin oil or mineral oil. Paraffin oil or mineral oil. Sodium is stored in the lab in mineral oil. So I gave example under each. No need to just to memorize that, then only you remember it. They will not ask all these 5 uses of activity series in the exam, right? They will not ask all these 5 uses of the activity series in the exam, maybe 1 or 2 maximum, right? Then the next most important thing, iron extraction, that one I'll discuss next day, because this one you are getting essay type questions in the oral paper. Please put 3 stars. This page extremely important for the O level, right? Activity series, put 5 stars with the red pen. This one put 3 stars with the red pen. You can, if you go through the parallel pathways, they have asked essay type question and structure this from this iron extraction, because iron is the most widely used metal in the world and it is the most abundant element in the earth, right? Iron in the earth, most abundant metal, iron. In the earth crust, most abundant one, aluminium. Earth crust, aluminium highest, second highest iron. Therefore iron, very important metal. Most of the things, so the stainless steel, railway line, train, vehicle, everything like the construction, we need iron. The alloys of iron, milled or hard steel, stainless steel, there are many alloys of iron, right? So that one I'll discuss next day. Then please, if you can, please recall all what to learn within 24 hours. Go through the notes, and if you can teach like me, even without an audience, alone in your room using a whiteboard, you will be very successful. Best method of studying is teaching to someone. Best method of studying is teaching to someone rather than just reading the note like a newspaper. Therefore, at least if you can tell all what you learned today, additional point, even the kitchen, what is happening, I told some example. If you can convey that message to your parents or the other members of your family, you will remember this very well. You will never forget it. Therefore, within 3 days, at least within 24 hours, that is the best thing. At least within 3 days, if possible, to deliver this knowledge to someone else. Those who are waiting or those who are struggling to study, maybe no problem. You may be your grandmother. You tell, sit in front of me. I am going to teach you this part now. Then ask them to raise some questions. Then you will be very knowledgeable. Right? That is the best method of studying. You will not fall asleep. If you are just sitting on a chair and just looking, reading the text, so within 15 minutes you will fall asleep. Right? It's boring. Therefore, find a suitable method before O level for studying if your current method is not successful, right? Okay, then we'll stop for today. It's almost 8:10 now. Have a good day and God bless you. Again, wish you all very happy New Year. Give my regards to your parents also, and I hope this 2020 will be very successful academic year for everyone, right? Okay, then God bless you all.